Hi guys, welcome to Algebra 1. Today's topic is going to focus on adding and subtracting polynomials. Now all that you know about simplifying expressions is really going to take you far in this topic. You ready to get started? Let's go. Okay, so let me take you back a bit to the distributive property, because you're going to apply it when you're working with polynomials, when you have to add and subtract them. You end up having to apply this a bit. So just to review, you remember the distributive property. If I see that 2 out on the left, I can distribute it throughout what's in my parentheses. And I bet probably somebody showed you like these little arrows to show you what you were doing. So I could say, all right, I need to multiply 2 times 4x, which is 8x. And I need to multiply 2 times positive 1, which is 2. So you could say, all right, 2 times that quantity 4x plus 1. After I apply the distributive property, I could write that as 8x plus 2, right? Let's apply that property a few more times. Get it in our system. Okay, so this expression, 7 plus 3 times the quantity x minus 2. Okay, for this one, I'm going to work down a bit. I think that might help this make a little more sense to you. Let's move that over slightly. Okay. All right, so the 7 is just kind of going to go along for the ride a bit. Let me erase that dot so you don't think it's subtraction. Okay. So 7 is just kind of go along for the ride for a second. So 7 plus. Now I do need to apply my distributive property here for the second bit. So 3 times x, that's 3x. And 3 times negative 2, because that's how I interpret that. All right, so 3 times negative 2. That's negative 6. So you'd write it as a minus 6. Then, okay, you look back at your problem, and you can combine some like terms here. Because you do have your 3x, which doesn't have anything else like it in that expression, so there's nothing to combine that with. So it's now just coming on down here. But I have 2 constant terms that I can combine to write it more simply. So 7 minus 6. Okay, so 7 minus 6, that's 1. So that means I can write that as a plus 1. So you applied the distributive property and you simplified that original expression to 3x plus 1. Okay? Let's keep going. All right, now this one. Let's do the same thing. Let's move that over a little bit. Okay. So I have 5 minus that quantity 3x to the 4th. Okay. That 5 is just going to go along for the ride for a minute. Now when you see something like this, I hope you remember, you have this minus and then this 3x to the 4th in parentheses. Treat that as if there is a 1 right in front of it. Because what's really happening is you're distributing a negative 1 throughout what's in your parentheses. Okay? So negative 1 times 3x, that's a negative 3x. And then negative 1 times 4, that's a negative 4. Okay, so now I'm at the point where I see I have like terms I can combine. This negative 3x doesn't have anything like it. It's the only term in this expression with an x. So I know that this is negative 3x. It's just going to bring on down. But I do have this 5 minus 4. Okay, so 5 minus 4, I know that's 1. And it's a positive 1. So I can write that as plus 1. So that original expression, it's simplified to negative 3x plus 1. Okay? Jogged your memory a bit with the distributive property? All right, so let's get into the polynomials. There are 3 steps to follow when you're adding and subtracting polynomials. You first want to rewrite the problem. Then you want to combine like terms. Then you want to make sure your final answer is written in standard form. Remember, standard form, that's when you have your exponents where they go in descending order. So the leading term has the largest exponent, and then you just go in descending order from there. So your final answer always needs to be in that form, okay? So while we're working with these problems, keep these 3 steps in mind. We're going to rewrite it, we're going to combine like terms, then we're just going to make sure we're in standard form. All right, so let's look at the first one. Deep breath, because I know it looks massive. There's a lot going on, but it's really going to break right on down to something that looks a lot more simple. All right, so our first polynomial is actually a trinomial. We've got 3 terms. So 7x cubed plus 6x squared plus 2x. And we're going to add that to 3x cubed minus 4x squared plus 7x minus 5. Okay, so we're going to start by rewriting the problem. And when you're adding polynomials, rewriting the problem is essentially just getting rid of the parentheses. Okay, so when you're adding, the rewriting is just break those terms out of the parentheses. All right, so I have 7x cubed plus 6x squared plus 2x plus 3x cubed minus 4x squared plus 7x minus 5. Okay, so I just broke that problem out of the parentheses. Now what I'm going to do, just so this doesn't get too crowded here, is I'm going to get rid of that problem. Because now we've broken it out of the parentheses. So let's just look at it by itself. All right, I think it's going to help us look at this a little better. All right, let's click off of it so I can write. Here we go. Okay, so now we're at step 2, where we need to combine like terms. So how I find out which terms are alike is the terms have to have the same variable raised to the same power. A coefficient doesn't need to be the same, just the same variable raised to the same power. Those are our like terms. And since we know that we need our answer to be in standard form, let's just start out with the largest exponent, so that we know that when we're at the end, more than likely we've got it written in the right form. Okay? So scan your terms, and you notice that you have a 7x cubed and you have a 3x cubed. So let's take those two terms first. I've got this 7x cubed and I've got this 3x cubed. And you notice how I took the sign out front because it tells me, you know, what the sign of that term. I'm going to come off and do some scratch work over here. Okay, so 7x cubed plus 3x cubed. Now here we're just adding like terms. We're not multiplying anything together, so we're not going to change the value of our exponents because we're not finding any products here. We're just combining like terms. So 7x cubed plus 3x cubed, that's just 10x cubed. Okay? Essentially, all you're doing is adding your coefficients and just carrying along that variable to that power. Okay? So I know we've got the first set handled, that 10x cubed. So, all right, that's out of the way. All right, go in descending order. So now let's look for exponents of 2. And I notice I have this 6x squared and I have this negative 4x squared. All righty, so let's combine those like terms. 6x squared, and I'm combining it with a negative 4x squared, so I'm just going to treat that like subtraction. So 6x squared minus 4x squared. All right, so remember, you're not really messing with your exponents at all. You're really just focused on the coefficients. So 6x squared minus 4x squared, well, 6 minus 4, that's just 2. So this is 2x squared. Okay? All right, now you've handled this. All right, so you handled the exponent of 3, you've handled the exponent of 2, so let's look for exponents of 1, which you really don't see. But here we go, I'm going to start squaring things now. Not as exponents, but just putting them in boxes to help me focus. Okay, so I have a 2x squared, and I have a positive 7, I'm sorry, I have a 2x, and I have a positive 7x. So I'm going to combine those like terms together. So 2x plus 7x. All right, so essentially I'm just combining like terms here. So 2 plus 7, that's 9. So this is 9x. All righty, so I'll combine those. 2x plus 7x, that's 9x. All right, that's taken care of. And all that's left is that lonely little negative 5. All right, so that's our constant term. I'm just going to write it down here. Okay, so now we're at the point where we can write our answer and just make sure it's in standard form. So I'm just going to bring all these little individual answers we got together. So I'm going to write this as, all right, let's see, the next thing to erase is give ourselves some room. Let's get rid of our problem because now we have the answer. And I'll write it right up here. Okay, let's get that out of the way. So when we added those polynomials together, it all really simplifies to 10x cubed plus 2x squared plus 9x minus 5. And that is our answer. That is what we get when we add those two polynomials together. And then you can double check, and we do have it in standard form. Our exponents are going from largest and then to in descending order. Okay? Ready to try another one? Let's do it. All right. 10a cubed minus 3a squared plus 4. And we're going to add that to negative 6a cubed plus a squared plus 1. All right, let's bring that up a little bit. Okay, so remember step 1 is rewrite the problem. And when we're adding, essentially that's just breaking the terms out of the parentheses. Okay, so 10a cubed minus 3a squared plus 4. Okay, so now look here. You see we have plus this negative 6a cubed. We don't like to have the signs bump into each other like that. So instead of writing plus negative 6a cubed, I'm just going to write minus 6a cubed. Didn't change the meaning at all, because adding a negative means the same thing as subtraction. Remember that from pre-algebra. So I can just rewrite plus negative 6a cubed as just minus 6a cubed. Okay? And then just break the other terms out of parentheses. A squared plus 1. Okay? So now we're at the point where we can combine like terms. So I'm going to give us a little more room up here. Let's get rid of our problem. And let's bring this up. We can get some space to work. Alrighty. So now look for your like terms you can combine. So essentially you're looking for the same variable raised to the same power to identify your like terms. I see I have this 10a cubed and I have this negative 6a cubed. So I can combine this one and this one. I'll come off and do a little scratch work. So 10a cubed minus 6a cubed. Basically, you're just subtracting your coefficients here. So 10a cubed minus 6a cubed, that's 4a cubed. Because 10 minus 6 is 4, right? All right, you've handled that. Looking for your exponents in descending order. So you scan your terms, and you see you have this negative 3a squared and this positive a squared. So those are your next two you're going to want to combine. So negative 3a squared plus a squared. Okay, you remember when you don't see a coefficient, there's an invisible 1. So negative 3a squared plus 1a squared. That's just negative 2a squared. Okay, so you've handled those square terms. Now I see I have two constants left. I have this positive 4, and then I have this positive 1. Alrighty, so 4 plus 1, that's 5. And you've combined all the terms you can combine, so you're ready to write your answer. And I do have some space over here, so I'm going to write it right here. So essentially just bring all those individual answers together, since we kind of worked out our problem in chunks. So 4a cubed minus 2a squared plus 5, because that 5 down there is positive. And you are all done, because we have it in standard form. All right, starting to feel a little better about it? Let's try another one. It usually takes 3 to kind of feel like, okay, I think I got it. I think I'm kind of ready to try one. Okay, so here we have 8b to the 4th minus 5b squared plus b. And we're adding that to 3b squared plus 5b. Okay, so you remember step 1, rewrite the problem. And when we're adding, essentially that's just breaking it out of parentheses. Okay, so 8b to the 4th minus 5b squared plus b. We're going to add that to 3b squared plus 5b. Alrighty. So now we're at step 2, where we can combine like terms. So this is where I get us some more space to work. Get that out of the way. Let's bring that up a bit. Now let's get to work. Okay. So I scan the problem, and because I know I want my answer in standard form, I'm always going to look for the largest exponent first to start identifying where my like terms are. So I see this first term has an exponent of 4. It's the largest one, but I notice there are no other terms that have an exponent of 4. So there's nothing to combine that term with. It just keeps going along for the ride. So 8b to the 4th just continued on being 8b to the 4th. It didn't combine with anything. Alrighty? So keeping in mind that we're trying to go in descending order with our exponents, we look for powers of 3. We don't see any powers of 3. We look for powers of 2, and I do see a couple of terms that have a power of 2. I see this negative 5b squared, and I see this positive 3b squared. Okay? So I can combine those. Negative 5b squared plus 3b squared. All right, so remember, essentially, we're just focusing on the coefficients. So negative 5 plus 3, that's negative 2. So this is negative 2b squared. All righty, so we've handled that. And I see all we're left with here is 2 terms that both have the variable b, and those are our last pair of like terms to combine. So we have this b plus 5b. So b plus 5b. And remember, when you don't see a coefficient, there's an invisible 1. So 1b plus 5b, that is 6b. Look back at the polynomial, there's nothing else to combine. So now we're at the part where we can write our answer. I'm going to write it up at the top, so let me get that out of our way. We can get the answer up here. Alrighty. So let's bring our little individual answers all together, because we solved our problem in chunks. So 8b to the 4th minus 2b squared plus 6b. It's in standard form because the exponents are going in descending order. All done. All right, you ready to try one? Okay, how about 2? All right, so go ahead and press pause. Take a few minutes. Take your time and work through these problems. Take it in chunks, just like we did. It probably is a little more easier to manage that way. And when you're ready to check your answers against mine, go ahead and press play again. All right, you ready to check? Let's check these. All right, so that first one, 11y squared plus 3y minus 2 plus 4y squared plus y plus 5. The answer there, you should have got 15y squared plus 4y minus 3. All right, on the second one, we had negative 5x cubed plus 7x minus 1. And we were adding that to 8x cubed plus 3x squared plus 2x plus 2. And the answer should have got 3x cubed plus 3x squared plus 9x plus 1. All right, so if you want to see how I did that, keep on with me. Okay, so remember, step 1, when you're adding, essentially you're just breaking those terms out of the parentheses is the first step. So 11y squared plus 3y minus 2 plus 4y squared plus y plus 5. All right, so now that I've got it broken out of parentheses, give us some room to work. I'm going to get rid of that. I'm going to move this up a bit. All right, okay. So now you're at the point where you need to scan your terms, because you've got to find the like terms, because you got to combine. And because we know we want our answer to be in standard form, just go ahead and start looking for the terms that have the largest exponent first. Okay? So I see my largest exponent in this term in this polynomial is 2. And the terms that have that exponent are 11y squared and then this positive 4y squared. So I do some scratch work. 11y squared plus 4y squared. That's 15y squared. All right, so we've handled this. Now I see I have 3y plus 1y, right? So 3y plus 1y, because there's an invisible 1 there that I don't see. 3y plus 1y. That's 4y. All right, so I've handled those terms. And I have two constant terms left. I have this negative 2 and this positive 5. So negative 2 plus 5, that's a positive 3. Okay, and those are my last two terms that I need to combine. So now you're at the point where you can write the answer. Since we worked the problem in chunks, we're going to take all our chunks and put them together. So 15y squared plus 4y plus 3. That's how I got that first one. All right, can you see the next one? Okay, gonna bring that up a bit. Here we go. Negative 5x cubed plus 7x minus 1 plus 8x cubed plus 3x squared plus 2x plus 2. So remember, for adding, essentially your first step is to break it out of parentheses. So negative 5x cubed plus 7x minus 1 plus 8x cubed plus 3x squared plus 2x plus 2. All right, so I've broken it out of parentheses, and just to help us focus, I'm going to get rid of that original problem and just zone in on this one. All righty. Okay, so now I'm at the point where I'm looking for my like terms to combine. And because I know I want my answer in standard form, I'm going to start with my largest exponents first. I see that I have negative 5x cubed and this positive 8x cubed, right? So negative 5x cubed plus 8x cubed, that's 3x cubed. Okay, so you've handled those terms. Now I'm going in descending order, so I'm looking for x squareds. And there's only one little term that has an x squared. So it just comes along for the ride. There's nothing to combine it with. So I know 3x squared is just going to be around. Okay. Now I see I have 7x plus 2x, right? So 7x, funky looking x that time, plus 2x. That equals 9x. All right, so I handled that. And then I had two constant terms left. So I have this negative 1 combined with this positive 2. So negative 1 plus 2, that's a positive 1. So now we have all our individual chunks, and we just need to bring it together for our final answer. And I think I left myself enough space. I can write it right over here to the right. So 3x cubed plus 3x squared plus 9x plus 1. And that's how we got that answer. All right. Okay. So you've handled addition. Now let's go to subtraction. And I want you to think back to one of those early problems that we did in this lesson, where we handled this problem with the distributive property. All right, so to jog your memory, remember what we did on this one. We said, all right, we had that 5 out front. It just stayed along for the ride, right? And we had to subtract that quantity in the parentheses. So we said, okay, it's minus this. There's like a 1 here I don't see. So essentially, I'm distributing this negative 1 throughout this quantity in here. So negative 1 times 3x, that's minus 3x. Negative 1 times 4, that was a negative 4. And we said, okay, now we need to combine like terms. The negative 3x didn't have anything alike, so it just came along for the ride. That term right there. We've handled it. And then we had this 5 minus 4, and 5 minus 4 is 1. So plus 1. Okay? So you remember how we did this. The part that I really want you to focus in on this is that it was a subtraction type problem. It was 5 minus that 3x plus 4. And I want you to pay attention to what we had to do with distributing that negative 1. We have to use that same process when we subtract polynomials. Okay, look at this one. All right, so we have 8x squared plus 5a minus 4a squared plus 2a minus 6. All right, Let's give ourselves a little room here. I'm going to bring that up a bit. Okay. So you remember when we're dealing with polynomials and we're adding and subtracting them, the first step is to rewrite the problem. Now when we're adding, rewriting is essentially just breaking those terms out of the parentheses. But when we're subtracting, it's not just that. We have to distribute this -1 that's kind of invisible, that we're kind of not seeing. That's the extra step that's involved when you're subtracting polynomials. Okay, so I look at that first term, or that first binomial. That I'm just going to break out of the parentheses. Nothing's really going on with that one. But as far as this trinomial is concerned, the second batch, there is a -1 here that I don't see. It's kind of invisible. So I need to distribute this -1 to each of these terms before I can go any further with this problem. So -1 times 4a squared, that is, well, let's show the work just so it makes sense. All right, so -1 times 4a squared, that's -4a squared. Okay, so that first term is minus 4a squared. Now we need to multiply that -1 times the 2a. So -1 times 2a, that's -2a. So minus 2a. Now I need to distribute that -1 to that -6. So -1 times -6, that's a +6. So +6. So now that I've rewritten the problem, and because it was subtraction and involved me distributing that -1 throughout, now I can continue on to simplify this expression. Now it's pretty much the same as when we were adding. All right, I think I left myself enough room. I can work right here. All right, so I see I have this 8a squared minus 4a squared. All righty, so I know what I can do. I will get rid of this bit and show that work right there. All right, so 8a squared minus 4a squared, that is 4a squared. Okay, so I've handled this. Now I have 5a, and it's positive, minus 2a, right? So 5a minus 2a, that's 3a. All right, so you've handled those terms. And all you have left now is that constant term, that's 6. So it just goes along for the ride. You got a 6. So now we're at the point, because we solved our problem in chunks, we just need to bring all our chunks together, and then we'll be at our answer. So I would have 4a squared plus 3a plus 6. And you are all done. So subtraction isn't too much unlike addition. You just have that extra step where you have to distribute that -1 throughout that second set of terms. All right, let's try another one. Okay, 7y to the 4th plus 3y squared minus 1 minus 6y to the 4th plus 4y squared minus 2y plus 1. All right, so step 1, rewrite the problem. And because we are subtracting, keep in mind, we're going to have to use the distributive property for the second set. But for the first set, just break it out of parentheses. So 7y to the 4th plus 3y squared minus 1. All right, so now that I'm at my second set, remember there is an invisible 1 here. So there is a -1 because you're subtracting that you have to distribute throughout those 4 terms. So you have -1 times 6y to the 4th. I'm going to come over here. So -1 times 6y to the 4th. That's -6y to the 4th. All right. So minus 6y to the 4th. And I have -1 times 4y squared. So -1 times 4y squared. That's -4y squared. All right, so minus 4y squared. And I can see things are about to run into each other here. So let's just bring that down a little bit. Okay. All right, and then I need to distribute this -1 to that -2y. So -1 times -2y. Well, that's a +2y. All right, so plus 2y. And then I have this negative 1 times positive 1. All right, so negative 1 times positive 1, that's negative 1. So I have a minus 1 right here. All right, so now we're at the point where we can combine like terms. I'm going to get that last bit of work out of our way because we're going to need some extra space to get a little scratch work in. All right, so let's see. I know I want to go in descending order of exponents. So which exponent is my largest in this case? I'm scanning the terms. It's 4. All right, I have a 7y to the 4th, and I have a negative 6y to the 4th. So 7y to the 4th minus 6y to the 4th, that is 1y to the 4th. And I don't have to write that 1. All right, so I've handled that. I don't have any x cubed terms, I'm sorry, y cubed terms, but I do have y squared terms. So I see I have a 3y squared right here, and I have a negative y squared, negative 4y squared there. So let's combine those. 3y squared minus 4y squared. All right, so 3y squared minus 4y squared, that's negative 1y squared. All right, so now I've handled those. And I see I do have a 2y term. So that just is going along for the ride. I can squeeze it in right here. So 2y is just carrying along. All right. And I do have a couple of constant terms here. So I see I have this negative 1 and another negative 1. All right. Let's get some things out of our way here. This problem got large. All right. Let's get this out of the way. And let's do a little erasing. Let's bring some stuff up a bit. All right, let's bring that up. All right, and let's bring the work up. All right, now we got some more room for scratch work. Okay. All righty, so we were doing negative 1 minus 1. So negative 1 minus 1, that's negative 2. Okay, so now we have combined all the terms that we can. So we're at the point we can write our final answer. Y to the 4th minus y squared plus 2y minus 2. It's in standard form. We are all done. All right. I think you got one more in you. Let's try another one before you try them on your own. All right. Negative 5x cubed minus x squared plus 3x minus negative 4x cubed plus 4x squared. All right, so let's bring that up a bit, and let's get to work. All right, so that first polynomial, essentially I'm just breaking it out of parentheses. There's no multiplication going on out here that's telling me I need to do anything else. So negative 5x cubed minus x squared plus 3x. Okay, now I'm subtracting. So it's like I'm distributing a negative 1 throughout these terms. Okay, so I need negative 1 times negative 4x cubed. So negative 1 times negative 4x cubed. That's a positive 4x cubed. Alrighty, so plus 4x cubed. And then I have this negative 1 times 4x squared. So negative 1 times 4x squared. That is negative 4x squared. Alrighty, so minus 4x squared. Okay, so we've gotten everything out of the parentheses. We did our distribution. So now we're at the point we can start combining like terms. All right, so let's get this old work out of the way. Make room for some new scratch work. All right, so I know I want to go in descending order of exponents. My largest exponent is 3 in this problem. So I have a negative 5x cubed plus a 4x cubed. So negative 5x cubed plus 4x cubed. That's negative 1x cubed, right? Okay, so I've handled that. And I notice I have some x squared terms. So negative x squared minus 4x squared. So negative x squared minus 4x squared. That's a negative 5x squared, right? Okay, so you've handled the x squared terms. And then all that's left is that 3x. And there's nothing to combine with it, so it's just going along for the ride. Now we've handled everything we can as far as combining like terms, so we're at the point we can write our final answer. So we would have negative x cubed minus 5x squared plus 3x. Got it in standard form, so we are all done. Okay? All right, why don't you try a couple? Go ahead and press pause and take a few minutes, and then really take your time and work your way through these problems. And when you're ready to compare answers with me, go ahead and press play. All right, ready to check? Let's go. All right, for that first one, negative 6c to the 5th plus 5c cubed plus c minus 4c to the 5th plus c cubed minus 8c. That one was negative 10c to the 5th plus 4c cubed plus 9c. That should have been your answer for the first one. All righty. 5x cubed plus 6x squared minus 1 minus negative 2x cubed plus x squared plus 2. That one, 7x cubed plus 5x squared minus 3. All right, if you want to see how I did those, so for the first trinomial, essentially we just need to get it out of the parentheses because there's no multiplication of anything going on out here that I need to handle. So I would have negative 6c to the 5th plus 5c cubed plus c. Okay. And because I'm subtracting, there's like a negative 1 out here that I need to distribute throughout those terms. Okay, so I need to do negative 1 times 4c to the 5th, negative 1 times c to the 3rd, negative 1 times negative 8c. I'm going to come off to the side and do that scratch work. Okay, so negative 1 times 4c to the 5th, that's negative 4c to the 5th, right? So minus 4c to the 5th. Then I have negative 1 times c to the 3rd. So negative 1 times c to the 3rd. So that's negative c to the 3rd, right? So minus c to the 3rd. And then I have negative 1 times negative 8c. So negative 1 times negative 8c. That's a positive 8c. Okay, so that means I have a plus 8c. And if you notice, when you're subtracting, essentially those terms right there where I'm distributing that negative 1 throughout, their signs just become the opposite of whatever they were to start with. So if you started to notice that pattern, that when you distribute the negative 1, it changes all the signs in that second group, you can go ahead and jump to that step. That's fine. Algebra is all about the patterns that lead us to these shortcuts. But if you want to continue and do that distribution and really show the steps, that's fine too, because it'll get you really comfortable with exactly what we're doing here with this process. Okay? So just keep that in mind, and let's keep going. So we're at the point now where we can combine like terms. So let me get us a little more room here to work. All right, let's get that out of the way. Let's erase this right here. Let's get rid of that. And let's move this up. All right, now we got some room to work here. Okay, so I know I want my answer in standard form. So scan your terms. You're looking for the largest exponent first. And I see in this problem my largest exponent's a 5. So I'm going to combine negative 6c to the 5th with negative 4c to the 5th, right? So negative 6c to the 5th minus 4c to the 5th. That's negative 10c to the 5th, right? Okay, so I've handled those. I don't have any c to the 4th terms, but I do have some c to the third terms. So 5c to the third, and I see I have this minus c to the third. So 5c cubed minus c cubed, that's 4c cubed, right? Okay, so we handled the c cubed terms, and I see I only have two terms left, and they're alike. They're both c, or they both have the variable for c. So I have this plus c, and I have this plus 8c. They're both positive. So c plus 8c, that's 9c. All right. And I've handled all the terms in that polynomial. So now I'm at the point where I can write my answer in standard form. Alrighty, so I'd have negative 10c to the fifth plus 4c to the third plus 9c. And you're all done with that one. Okay, let's look at how I did that next one. All right. So for this one, let's move it up a bit. Okay. So what you want to do first, check out that first polynomial. There's no multiplication or anything going on up front, so just break it out of parentheses. So 5x cubed plus 6x squared minus 1. Alrighty. Now I'm subtracting, so remember you're distributing this negative 1 throughout these terms. So I need to multiply each of those terms by negative 1. I'm going to come off to the side and do a little scratch work. Okay, so for the first term, negative 1 times negative 2x cubed. So negative 1 times negative 2x cubed. That's a positive 2x cubed. Okay, so plus 2x cubed. Now I have this negative 1 times x squared. So negative 1 times x squared, that's a negative x squared. Alrighty, so minus x squared for that bit. All right, and then I have a negative 1 times this positive 2. So negative 1 times 2, and that's negative 2. Okay, so come up here, I've got my minus 2. And then you remember we said, you might have noticed, it just basically changes all the signs in that second bit when you distribute that negative 1. So maybe you took that shortcut, or maybe you did all the work like I did. Either way is fine. All right, well now we've reached the point where we can combine like terms. So let's give ourselves a little more room to work up here. Let's get rid of that. And let's get rid of this and get that out of our way. And move this up. Okay, let's start combining. I know I want my answer in standard form, so I'm going to look for the largest exponent first. I see I have 5x cubed, 2x cubed, so I can combine those. Okay, so 5x cubed plus 2x cubed, that's 7x cubed, right? Okay, so you've handled those two terms. Now you're scanning again. You see you have some x squared terms. I have 6x squared and minus x squared. So 6x squared minus x squared, that's 5x squared. Okay, so you've handled the x squared terms. Then you look again and you just have two constant terms left to combine. So I have this negative 1 and that negative 2. Negative 1 minus 2, that's negative 3. So now you're at the part where we can put each of our little individual chunks together and write our final answer in standard form. So 7x cubed plus 5x squared minus 3. And you are all done. All right? Okay, well I hope you really got a grip on how to add and subtract polynomials, and I hope you saw how the distributive property really helps you with those subtraction problems. Hope to see you back here soon for some more Algebra 1. Bye guys.